Alright, so welcome back to our UVA training series. So in this video, I will going to talk about these palindromes questions again. So it is called as magic square palindromes, which is in 11,221 21st questions. The problem statement is as follows. A magic square palindrome is a standard whose characters can be divided into k times k square table, which a property that the original sentence can be read from the table in 4 different ways. So the first way, you read from left to right, and left to right, and left to right, left to right, until the end. And the second way, you read from top to down, SATOR, AREPO, and so on. And start from K cell, move from left until the beginning line and proceed to the previous line, which is here. It's actually same with the first case but in reverse order. So the fourth case is same with the second case but in reverse order. So this case is probably the most famous magic square palindrome. We can arrange it in k equals to 5 times 5 table in the following way. Notice that the original sentence can be read from the table in 4 different ways described above. So if we were to compare the first and the third statement, so the result from both statements, we can find out the strings is actually the same for this case, and the second and the fourth one are also the same. So this is a magic square palindrome. So the input, first line you will be given number of lines you need to check, which contains a line. The length is 0 to 10,000. Is the sentence that contains A to Z, so on, blah blah. So please notice that the magic square palindrome table ignores all the white space and punctuation symbols. So in this case, we are going to ignore the space here, the comma here, the dot here. So the output is comprised of 2 lines of each input data sets. The first line identifies the data set with a number starting from 1 and incrementing at new data sets. So case 1, case 2, case 3, and so on. So the second line gives the dimension of the magic square palindromes, the k value or the expression no magic if it's not a magic square palindrome. So for this case, it's 5 times 5 magic square palindrome, so we print out the dimension of it, which is a value of k5 in this test case. And for this test case, it's not a magic square palindrome, so no magic and a set emoticon. And next is a 5 times 5 magic square palindrome again, so we print out dimension of 5. So let's just see the codes. Okay, on the first line, we need to remove any punctuation space and so on. And the question say the input is only consists of lowercase, so we don't have to convert it. Consider the case with uppercase, which we need to convert all into uppercase or all into lowercase to ensure the consistency. Such a this case doesn't happen. We don't have to change the point because the inputs are all lowercase. Okay, so we process the string such that it doesn't have any white space and signs and so on. So clean. This is our string that we want to put into the table. So first we square root it, then we multiply back the square root. So if the length of the clean is a perfect square which fits the square table, then we continue checking. Otherwise, it's not a magic square palindromes apparently, because it's not a square. It's not a perfect square. We can't put it into a square table. Next, if it's a perfect square, then we proceed to put in to the square table. So case 1, which contains the case of this one, the first one, and the third one. So actually, we don't have to create the string for this case, because we can check this. Then we have already covered this case, because it's basically the invert from the first case. So this is read from left to right, and this is read from right to left. So first, we check again the clean one, which is from left to right, then right to left. So in this case, it is the first and the third case. So this is, we need to check whether at this stage whether it's a palindrome or not. Okay, so it's a palindrome, then we continue. Although if it's not palindrome, then we skip the remaining checking, because it's not a palindrome apparently. So for case 2, we will construct a string based on up to down. Then we check the up to down, back and forth. So whether the string generated for up to down is a palindrome or not. So this will cover the case second and the fourth. So if it's not a palindrome at this stage, so you ignore, you print out no magic. So same with the first case, no magic if it's not a palindrome. Otherwise, if it is a palindrome, then in both cases, then we will print out the dimension of the square, so which is the value of k. So that's it for this question. If you have any problem, please leave a comment, and see you in the next video.